Okay, so in this video, we're going to look into titrations. Now, titrations is a process in which you use a known concentration solution, um, and through a reaction, you could figure out what is the concentration of some unknown solution. All right, is this really works well, especially with acid-base reactions. All right, because we know if we know the substance, and we can know exactly what the products. But the cool thing is that we can also use the quantitative data, like the volume and the concentrations, and the volumes and the concentration, to figure out what's the concentration of your unknown solution. All right, so let's kind of talk about quickly how this titration works. But basically, in titration, a you will have a burette. Now, a burette is basically a equipment that allows you to control how much of a solution or any liquid has been dispensed over a period of time. And so it has all these calibrated marks, and then you have this basically this knob over here. When you turn the knob, then it'll be dispensed in a very controlled manner, and then you could kind of watch and measure how much of that liquid has been dispensed. Now, that liquid will be dispensed in some type of container. So Erlenmeyer flask or beaker typically kind of works well. And so what's the case here is that you will have something down here, right? You will have some type of solution. This solution here, right, in here is what we call an analyte, while this solution in here is what we typically call the titrant. Okay, so essentially you're going to be mixing these two together, right? The titrant's going to be flowing to the analyte, and this is going to continue to react until you reach what we call an endpoint. All right, and usually the endpoint is about the time where you have equal number of acid molecules as for your base molecules. All right, and then so you reach this endpoint here. Now, usually you would have some type of indicator which will give you some type of visual clue that you have reached this endpoint. All right, and so that part is important. And then the titration ends. All right, and so what you typically would know that you will know. So like, let's just say, for example, here you will know the concentration of the analyte and the volume of the analyte you started with. For the titrant, you know the concentration of the volume, and you may be trying to figure out what's the concentration. Okay, so how do we go about figuring out, okay, what is the concentration of the titrant? All right, and so what we could use this equation: molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. Now, this only works where you're dealing with two monoprotic substances. If the acid is monoprotic and the base is monoprotic, or if you're dealing with two diproducts or two triproducts, all right, where the product or the product, the product portion, the hydrogen portion is the same. Okay, then we could use this equation. If not, if you're dealing with like a diproduct with a monoproduct, all right, and so, like, for example, if you're dealing with so two monoproduct products, so it's like hydrochloric acid plus NaOH, right? One hydroxide, one hydrogen. So these are two monoproducts. But if you're dealing with like sulfuric acid, which is a diproduct, however, plus sodium hydroxide, which is basically a monoproduct because it only releases one hydroxide, then what you want to do is use this equation, equivalent of the acid, which is also equal to the equivalent of the base, or specifically the normality of the acid times the volume of the acid is equal to the normality of the base times the volume of the base. Okay, And so just kind of depending on what information is given to you, all depends on which equation will best fit whatever you're trying to do. So let's look at this example problem here. So how many milliliters of a 0.150 molar of NaOH are required to neutralize 50 mils of a 0.200 molar of H2SO4? The balanced neutralization reaction as shown, right? H2SO4 plus 2 NaOH yields Na2SO4 plus 2 H2O. All right, so one thing that you need to quickly realize is that you're dealing with a monoproduct base here, but a diproduct acid. All right, and so it's best to go into normality so that way we could normalize it, right? And then that way I think it'll be easier to figure this out. And so when you think about, remember, normality is just basically the equivalent, which is 1 mole of a charged particle divided by the liters of solution. All right, but then when we're looking at H2SO4, all right, we see that if you have 0.20 molarity of H2SO4, we see that for every 1 molarity of H2SO4, we have 2 molarities of H pluses. All right, so this concentration in normality, all right, so this is kind of going to normality, is 0.440 normality of H2SO4. Okay, and for the sodium hydroxide, since it's a monoproduct, so 1 molar of NaOH is also equal to 0.150 normality of NaOH. All right, it's a 1-to-1 ratio, so it kind of works itself out. So we could use these numbers. So remember, normality of the acid times the volume of the acid is equal to normality of the base times the volume of the base. Okay, and so let's kind of look at what we know. Well, we're trying to find specifically how many milliliters of the base. So we're looking for VB. Okay, so we could rearrange this equation to solve for VB. So VB is equal to NA VA over NB. All right, normality of the acid is 0.400. The volume of the acid is 50 milliliters. The normality of the base is 0.150. Okay, and so when you plug this into the calculator, you get, so the volume of the base is going to take roughly about 133 milliliters, which is expected, right? Because sodium hydroxide is a monoproduct, so you need almost twice as much just to neutralize a 50 mils of a diproduct substance. All right, so this concludes this video.